Hello there. Have you guys ever ordered a t-shirt, either from online or maybe you filled out a form and got your kindness crew t-shirt from school, anything like that? I have noticed that if I order a t-shirt, I have a certain size. You might have a certain size in your mind that you're like, usually I wear this size. And you order that size, whether you're buying clothes online or ordering from a catalog from school or something. And sometimes the clothes arrive and it fits just fine. And sometimes I ordered my size and it doesn't fit very well. I have particularly noticed that this seems to happen to me more often when I order a women's t-shirt than it does, say, to my husband when he orders a men's t-shirt. So it seems like t-shirts seem to work out a lot better for him when he orders them than if I order them. His will fit and mine don't always. So that made me wonder. I looked up online. I'm going to share something with you real quick here. Often when you're ordering something online, you'll see some kind of sizing chart like this. And they're usually split into two categories, men's and women's, because those things are sized differently. And they'll have different measurements listed on their charts. So I was curious about whether or not there is more variation in these measurements in men's tees or more variation in women's t-shirts. So I focused just on one measurement. You can see the shoulder to hem measurement here is what they're calling the length. And I wanted to stick with just one sizing group, and I wanted to kind of make it easy to gather my data. So I just went with the smallest one that's usually listed. Some sizes have an extra small as well, but a lot of t-shirts just start with size small and go from there. So I focused on the length measurement from shoulder to hem, and it's measured in inches. So like this men's t-shirt has a length of 28 inches and this women's t-shirt has a length of 25 3/8 inches, which for my data, I just went to the nearest half inch to kind of keep things simple. So I would have listed that as 25.5 inches. So that is what we're going to look at. First though, let's get our spiral notebooks out. Let's make sure we have everything set up correctly. So let me bring up for you what you should have in your table of contents so far. This was our week 1. This was week 2 last week. And now we are well into week 3 here. So this is what you should have on here so far. You should have the Who is the Better Saver? Watch that video. You should have those notes on page 11. You should have also tried the MLE 4A, the one mad problem all about the birds. And I hope you wrote down your work and everything, because that one's a lot to keep track of without. So I hope you wrote everything down on page 12. And now you need to add this one. Today what we're working on is comparing data with the mean absolute deviation. Remember, MAD stands for mean absolute deviation. And we're going to focus on the t-shirt measurements, men's versus women's t-shirts. So make sure you got this all written down. Let's all flip to page 13 and make sure you also have page 13 written down in the corner down here. So we are working on page 13 here. Give this page a title. And you can also take a second and write down this information that I have. This is what I'm going to be comparing. I'm comparing the lengths of women's t-shirts compared to the length of men's t-shirts. That's that shoulder to hem measurement that I showed you, and all this data is going to be in inches. And I did exactly what I just showed you. I Googled, like that one chart would have given me one piece of data for the women's t-shirt and one piece of data for the men's t-shirt. And I found 10. I just found 10 different t-shirt sellers, places online that you can order a t-shirt. I looked at their size chart and I wrote down for size small, what is the length of that? So these are all size small length of the t-shirt in inches. And I got 10. I could have gotten a lot more. There's plenty of places that sell t-shirts. I stopped at 10 because, as you've probably noticed with mean absolute deviation, it kind of becomes a lot to get this value, because you have to find the mean of all of your data. You have to find how far away every single data point is from the mean, and then you have to calculate the mean of those differences. So it does kind of become a lot. So I just stopped with 10, even though I could have gotten a lot more. So first I'm going to show you the women's data. And I want you to create a table just like I created here. All I did was write W for women's. These are the women's t-shirts. And you can start, it was easiest to kind of format this by listing all 10 of these numbers under the W first. So these are the measurements I found just by going with the first 10 charts that came up. I Googled women's t-shirt length size chart, and then I clicked on images because it was easiest just to look at their image charts. And these were the first 10 that I found, just from various t-shirt companies that sell t-shirts online. So we got 22 inches, 28 inches, 26.5 inches, 24, 24, 26. Here's the one that I just showed you, 25.5 inches, 25 inches, 22 inches, and 25 inches. Of course, you can pause the video if you need to get this set up, but you want to list all of those values. And then I drew a line across here because I know I need 3 total columns. I need the column with my actual data, I need this middle column, and I need this column that says difference. So make sure you get that all set up with your columns. Once you're ready with that, what are we going to put in the middle here? Well, we are going to calculate MAD, the mean absolute deviation. So in order to figure out how this stuff deviated from the mean, I, of course, need to calculate the mean. To calculate the mean, I hope you're getting this part right because MAD is very difficult if you don't get the mean right. It messes everything else up after that. So to get the mean, I add these up, 22 plus 28 plus 26.5, and it's easy to just type it all in the calculator. And then what should I divide it by? Once I get that sum, I add them all up, and what should I divide it by? 10. Why? Because I have 10 pieces of data. I did 10 t-shirts. And when I did that, I added those all up and I divided by 10. I got 24.8. And that value, I'm just going to write that value all the way down this middle column because that value does not change for my data. That is one central measurement for this entire data set. And it's a valuable number. It tells me from all the data that I found, the average length of a women's t-shirt was 24.8 inches. That was the average. Now, that's not especially helpful to me, though, to know if there is a big difference in these, okay, meaning women's versus men's. So let's just pause right here for a second, and let's come over and get our men's data written down, because as I pulled up those size charts, there were men and they were right next to each other. So I gathered all the data at the same time. So I got those 10 women's lengths. I added those up, divided by 10, and got the average for the length of a women's t-shirt. Okay. Then I did the same thing. I came over here and I used a different color. I used red for men's, but I did the same thing. I set up another table next to it. So again, you can pause this video to give yourself more time if you need it. But this is the list of the men's t-shirts that I found. Again, this is all the length, and I just stuck with size small because obviously if I change sizes, that would get really confusing. So this is all size small of the men's as well. So this is size small length on a women's, size small length on a men's. And I'll let you get those all written down. And then of course I did the same thing. I added them all up, 28 plus 27 plus 28 plus 26. And what did I divide by? I divided by 10. Why? Because there are 10 t-shirts. So the mean is going to go here. When I added those all up and divided by 10, I got 27.4. I'm going to write this all the way down this middle column because that is the central value for all of my data. Now, I'm not surprised by the fact that this mean value for the men's length of t-shirts is higher than the mean value for the women's, because that is one key difference in sizing, is that men's t-shirts are longer. But that's really all that this mean value tells me. That comparison simply says men's t-shirts are longer. Well, that's something I really already knew. I knew men's t-shirts were longer. My question really is there more variation in women's t-shirts? Is there a bigger spread in the lengths than there is in men's? Is that why my shirts don't always fit quite like I want to, and my husband's t-shirts seem to fit him just fine? That's my big question. So here is what I want you guys to try, because we're practicing this whole idea of MAD. Remember, this next step, the reason I have this column of difference is I need to go through and I need to subtract the actual data minus the mean. And remember, if it's negative, you just drop off the negative. That's the absolute part. Mean absolute deviation means how far are we from the mean, and I don't worry about negatives. Okay, so I'm going to do, and the negative, that just means you're below the mean, and a positive means you're above the mean, but I just don't worry about those parts. So I'm going to give you a chance right now. You guys are going to pause this video, pause the video, and you are going to try and subtract all of those values and see if you can get the difference column for the women and the difference column for the men. Okay, pause the video, give it a pause. Ta-da! Here they are. How'd you do? Remember, these values simply came from how far away are we from the mean. Now, the women's mean was different than the men's mean, and that's fine, that makes sense. As you're calculating the difference, you are finding how far are you from that data's mean. So how far are we from 24.8 for the women's? How far were we from 27.4 from the men's? Now, we still haven't actually calculated the MAD. This is a kind of long process, but just to recap, here's what we did. We took our original data, we calculated the mean, and we found how far all 10 of those t-shirts were from the actual mean. We did the same thing for the men's. Now, the last step in calculating the MAD, two more steps really, I guess, we're going to calculate the mean again. What we're going to do at this point is, instead of calculating the mean of the actual data, we're now going to calculate the mean of the differences. So the first thing I need to do is I need to total up all of those differences. And I did that for you already. I typed in 2.8 plus 3.2 plus 1.7 plus 0.8 plus 0.8. I added those all up and I got a total of 14.4. Tell me guys, what am I going to divide that by? Yes, 10. I'm going to divide them by 10 because it's still 10 pieces of data. Divide it by 10, and what I have is I have the women's t-shirt MAD. The women's MAD tells me how far my data is spread from 24.8. The women's MAD is 1.44, and I can label it with inches because all of this is calculated in inches. So this means that if you order a women's size small, that means that your sizing could be 1.5 inches difference one way or the other, which actually is almost more like 3 inches of variation, 1.5 on this side plus 1.5 on this side. And if you imagine 3 inches, your thumb is usually about 2 inches. 3 inches that's quite a bit of difference in length, which helps understand why if I order a t-shirt and I order a size small, it could be this much longer or this much shorter than what I expect it to be. And sometimes that's not quite right for me or for what I want. So that helps me understand why when I order a women's size small or whatever size I'm getting, it's not always quite the length that I expect or that I want, because that's 1.5 inches off is kind of a lot when it comes to the hem length of your shirt. Well, let's see how that compares to the men's information. So again, we're now totaling up this difference values, the difference values. The total of those, when I added up all those decimals, I got 6.4, and I'm dividing that by, once again, 10. There are still 10 pieces of data. So the men's MAD, this shows me the variation in their t-shirt lengths, is only 0.64 inches. That 0.64 inches is kind of like 1/2 inch about. That's almost 1/3 of the variation of the women's. So that helps me understand why when my husband buys a t-shirt, it's pretty much the length he expects, because it might be 1/2 inch above or below what he's used to, and he's not going to notice that as much as 1.5 inches off, shorter or longer. So what does this tell us? This is a comparison now, and this information is maybe a little more telling to me, a little more useful to me. These tell me more about the sizing of the t-shirts than just the average did. All the mean told me is that men's t-shirts are longer, something I already expected and already kind of knew. This now tells me something more. So I'm going to skip a line and I'm going to draw a star right here, and I'm going to ask myself here, what does the MAD tell us? What does this even help us to know? Okay, so in comparing data, once again, this is really where statistics becomes the most useful, is when you're taking two different groups and trying to compare them. Well, what this tells me about the MAD, or about t-shirts, is this tells me that men's t-shirts, and I'm actually going to say men's t-shirt lengths, have less variation. And I know that because the MAD was smaller. So men's t-shirt lengths have less variation in their, how do I want to say it? We'll say in their sizing. Okay, men's t-shirts lengths have less variation in their sizing. And we'll say women's t-shirt lengths have more variation. And that is simply because their MAD is bigger. But I can even be more specific than that. I can say that women's t-shirts, I can give more statements. Men's t-shirts are all about within ½ inch of the mean. And so I'm going to change colors here and I'm going to add a little bit more to this statement. I'm going to say that, well, let's use some, I don't know if you guys can see this bright green very well, but I'm going to say that men's t-shirts are within, this means they're within 0.64 inches of the mean. And that is what we mean by less variation, is that their t-shirts, the t-shirt lengths are all closer to the mean, where the women's t-shirt lengths are a little bit more spread out. Okay, so this MAD process can take a little bit of time, right? And when we finish this, we're going to write a couple more things down here to make sure we understand just the general idea of mean absolute deviation. When you finish this and you try your MLE that's next, it's an MLE to practice MAD, but it's also to show you exactly what your assessment this week looks like. You're just going to calculate MAD a few times, and then you're going to compare them, and you're going to tell me which one has more variation, which one has the highest MAD, which one has less variation, which one has the lowest MAD. The longest part of that process is, of course, calculating the MAD. You have to do the average. You then have to find the difference of every data point from the average, and then you have to average again. But it's all mathematics you absolutely know how to do. If you take the time to write things down in your notebook and keep a list of your differences, then you'll be just fine. And very carefully calculate the mean. Because if I got this number wrong in the middle of my column, all this stuff would be wrong and that would mess up my MAD. So what if we just do a couple more examples? I'm going to skip a line here and I'm going to say, do you really understand MAD? Do you really understand MAD? And just to kind of check for understanding, instead of making you calculate it a couple more times, what if I just told you a couple pieces of information, okay? Let's just write down 2 examples here. And I'm going to write with pink this time, and I'm going to say, okay, do I really understand math? So just a quick sentence here. What if I told you 7th graders, I always do that when I write 7th, I try to write the H too fast, 7th 7th graders at Riverview have, let's say this, have a mean of 2 siblings. I'm going to put comma. So 2 siblings means not including them. That means that they are them and then they have 2 siblings. So that would be like 3 kids in their family. 7th graders at Riverview have a mean of 2 siblings with a MAD of 1. Do we really understand what that means? Let's write another statement, and I'm going to use purple here. Let's write another statement to tell ourselves what that means. What this really means is that most 7th graders, now if the mean is 2 and the MAD is 1, that means we could either be 1 higher, so 3, or we could be 1 lower, so 1. So most 7th graders have between, let's start with the lower one. 2 minus 1 is 1. 2 plus 1 is 3. So most 7th graders have between 1 and 3 siblings. That's what the MAD tells us. It tells us how it's spread out. Okay, this is the mean, this is the central value of 2, but if the MAD is 1, then that's only 1 higher or 1 lower. That's not a lot of variation. That's pretty low variation, a MAD of 1. okay? But that's what it actually tells me. Most of the 7th graders have between 1 and 3 siblings. One more example. Let's say, and I tried to kind of accurately calculate this to my best guess, but I don't have the official data in front of me. But let's say one more statement here. The teachers at Riverview. The teachers at Riverview have a, okay, the teachers at Riverview have a, you ready for this? Have a mean age. This is their age in years. What do you think the mean age of teachers at Riverview is? My best guess, based on my calculations, the teachers at Riverview have a mean age of 39 years old, with a MAD. Do you think it's only a MAD of 1? Are we all within 1 year of each other? Or do you think it's a bigger variation or a smaller? The mean age is 39 with a MAD of, you ready? A MAD of 12. That's definitely more spread than something like how many siblings we have. That's because some of us are younger, some of us are older, so it's spread out. So the average itself, you can't say every teacher at Riverview is 39. That's not a good representation, but I can say the mean age is 39. And then if I say the MAD is 12, that tells me how far I'm spread from 39. So this tells me most teachers, and I keep using this word most because you'll notice the MAD really doesn't encompass all of it. It gives that main bulk of spread. So I can't say all, but I can say most. So I'm going to say most teachers at Riverview are between. Okay, so 39 minus 12 is 27. So most teachers are between 27 years old and, now I add to the mean, 39 plus 12 is 51. That is what the mean allows you to do. It allows you to give kind of a range of where the data is, not just that one central value, but how spread out is it? And this is especially useful when you're trying to compare data and you're trying to give a better comparison than just, okay, this average is lower, this average is higher. Well, no duh, women's shirts are shorter, men's shirts are longer. I knew that. I want to know if there's more variation. And this shows me, yes, in fact, there is. There's more variation in sizing in women's shirts than men's shirts. And that's what the mean absolute deviation shows you, is how far away from the mean does all of the data get. So you guys are going to try your practice test, and you guys are going to then watch a silly little song video about MAD. It's super cringy, but hopefully helps you just really solidify what it means. And then the last thing you have to do is take a little assessment on MAD. Email me if you have questions. Let me know if I can help you in any way. You guys got this. You're doing great.